So we'll start now. Yeah.
Okay, sir.
Yeah. Gayatri, you can introduce.
Sure, sir. Welcome back, everyone. Now we are going to have a lecture on Introduction to Permission Blockchains, Applications, Research and Challenges by Dr. Vigneswaran R. Dr. Vigneswaran is a researcher in Cybersecurity and Privacy Research and Innovation Group, TCS, India. His current research focuses on privacy and security aspects of permissioned blockchains. He has completed MCA degree from Bharatiya University, Coimbatore, and completed 16 years with TCS. He has worked on domains like Indian language computing, virtualization, high availability, network routers, and securing information on computing services. Over to you, sir.
Thank you. Thank you for the introduction. By the way, I am not a PhD holder. Uh, so, uh, so today I will be talking about permission blockchains. So the thing is, when when I commit some kind of talks and things like that, I usually get confused. Okay, what level I can speak and things like that. So what I usually do is I try to make it more interactive, so that maybe it will be I can try to answer some specific questions and things like that. So I'll start with my generic presentation, whatever I have prepared for. But we can have question answer session a bit elaborate. I have presentations for little less time only. Let me share my screen first. So what I will do, I will cover. So maybe yeah, I can show you here. In the agenda, let me start with basic what is blockchain, some high level overview, then permission and permissionless. So we are working on permission only predominantly. Just for completion, I'll touch upon permissionless also, and what are the building blocks of blockchain and smart contracts, then blockchain benefits and some use cases, and what kind of use cases a blockchain is good for. And then a technique. So this I will cover in the morning session, and then in the afternoon session we will see technical and non-technical challenges, what are the research associated with that, and how to choose a problem, whether how to decide whether a problem is a blockchain problem or not. And the conclusion we will see in the afternoon session. Hope that's fine. So I'm just starting with blockchain. By the way, you are able to see my screen, right?
Yeah, you can see
Okay.
it.
Okay.
Yes, sir.
Oh, yeah. Thank you. So you know that you may know that, right? It's a database, right? It's for persistent storage, just like a database. We can store data in the blockchain, and it is decentralized. Decentralized in the sense that uh, database is a centralized place, right? All the data get into the database and multiple people can access it. But decentralized means multiple people will have a copy of it and they independently write into it. It is not like a master slave kind of relation that one person writes into it, other replicate it. It's not like that. So one person, everybody individually write into their own copy of the database. That is the blockchain. So that's why we say it as decentralized, the controlled by multiple parties, and it is up and only. So when we take a database, we can add to it, update it, or delete it, right? So here we can only append the data. You cannot modify or delete. In case you want to change some already existing fact, you need to put another transaction which will update it, but there is no direct update. So it's like a transaction history. So then cryptographically verifiable. So when we say cryptographically verifiable, if you take a database today, if you have a value of something, a ledger balance is 20 rupees, and tomorrow it becomes 30 rupees, there is no record by default in database. It's not there is no record kept, right? Unless we have external data table for transaction history, there is nothing maintained. But in blockchain, that record is maintained, means every addition or every change is a record, and those records are stored in a data structure called blocks. So multiple blocks are chained. How they are chained? They are referring the previous blocks hash in their thing. So hash will come later. Anyway, I assume all of you know that. So hash is kind of fingerprint, right? If somebody wants to modify anything, automatically hash will be changed. So cryptographically verifiable, what we mean that is, we can verify the hash of the block and say that okay, the previous block hash is the same, and so it is valid. There is no tampering happened in the transactions inside the block. So that way cryptographically verifiable. So that means integrity of data we can verify, and also highly available. And since there are multiple copies of blockchain database, we can, it is obvious that it is highly available. Even one server is down, we can get the data from another server. So that is the blockchain fundamental. So before moving to the further about blockchain, we will quickly see the difference. So you might have seen permission blockchain, permissionless blockchain, cryptocurrencies and things like that, right? So uh, when we say permissionless, that means there is no permission required to join the network. Anyone can join, like Bitcoin network, Ethereum network, and you can download the software and you can run it to join. So with minimal configuration, you can join that one. But permission thing mostly used by enterprises, their prior permission is required. You need to complete the KYC kind of formalities. Then only we will get the key and information to join their network. So the initial onboarding process will be there. For example, Hyperledger Fabric, Corda kind of blockchain platforms. There are so many. And when come to permissionless, the consensus mechanisms such as proof of work and proof of stake are being used. They are slow because of the nature of permissionless, right? Everyone can join. So the consensus would can be some of these things. People are working on improving it. We will see later. And coming to permission, relatively faster consensus mechanisms such as Raft, Kafka, and PBFT can be used. So it is more efficient when compared to permissionless system. Then again, more suitable permissionless is more suitable for public hosting kind of use cases. For example, cryptocurrencies, Bitcoin kind of cryptocurrencies, voting, crowdfunding, digital identities. So several use cases may come under permissionless as well as permission, depending upon where we use. So voting, if we take public voting, then we can think of permissionless blockchain. And if it is a private voting within an organization or things like that, we can consider permissioned blockchain. And in general, permission blockchains are more suitable for enterprise use cases such as cross-border payments, goods tracking in shipping industry, land titles. So here, public has nothing to do, right? All the parties involved only need to see the details. So permission blockchain we can use. And so permissionless is a complete decentralization. So absolutely there is no authority over there. But when we come to permission, mostly there will be some consortium. They onboard the new parties and they take care of the things. So it is a kind of partial decentralization. So moving to the next one, again, the application point of view, how it looks like for application, whether it's a blockchain application or database application. So this is an existing model, the conventional centralized model. The presentation tier has application UI, a logic will be there in the backend server, what to do. So UI communicates with the server and asks for something. And the data tier will have the database. So, and database engine and storage. So this is the conventional centralized model. And when it comes to the blockchain applications, again, presentation layer has its own user interface, and logic layer can either have a legacy application. For example, if we are integrating blockchain to some existing application, then the existing application will have the logic and things like that. Another mode, you can directly, user interface can directly interact with blockchain peers. So this is a blockchain network. in every peer, we can assume that smart contract and blockchain storage is there. So smart contract I will explain in shortly. So multiple copies are there maintained by multiple independent parties. Okay, this is the blockchain network. And when we use through legacy application also, you can insert the data, or you can directly insert data into blockchain network. So we can see that blockchain comes in spans across two tiers, like logic tier partially and data tier. So logic tier means smart contract also can have some kind of logic, right? Some amount of logic can be there in the smart contract. I'll come to it in the next slide. So it is between here. Coming to the next one, so database versus blockchain. So some comparison, like database is centralized, no consensus required. So but blockchain is decentralized, so consensus is required before storing anything. Whether everybody is storing the same data, we need to check with them, right? Otherwise, independently, when we write into database, we may end up writing different values. So we need to take a consensus. Once all majority of people are sure about we are all entering the same data, then only we can store the data. Similarly, in database, updates allowed, but in blockchain only up and only, there is no update allowed. Direct in place changes are not allowed. And database is more structured storage, data storage. You can say RDBMS kind of structure will be there, so the queries will be efficient and things like that will be there. And complex queries might be possible. But in blockchain, it is less structured data storage. It's like a key value pair storage will be there if you take Hyperledger Fabric kind of blockchain. And yeah, as I mentioned, more efficient reads and writes. Here it is less efficient due to overheads also. So previously, when we write into database, it's a insert. But if you write into blockchain, it requires consensus, etc. Right? So it is less efficient. And database data archival is possible, but in blockchain, data archival is a challenge, because data are up and only. So in order to verify the validity of some data, we may need to look into the previous data. So things like that are there. So here is an representation of Bitcoin blocks. More or less, all the blockchain blocks are very similar. They contain previous hash, the timestamp when the block was created, the transaction root. So there are list of transactions come there, and their hashes are converted into a Merkle tree form, arranged in a Merkle tree format, and the root hash will be there here. And the nonce, which is the um, random value to generate the hash of particular complexity. So these are all the things in the block. So blockchain building blocks. So what are all the things needed for these blockchains? So underlying concepts, the hashing and digital signatures are two important building blocks of blockchain. So hashing is the fingerprinting or digest of input data. So we are giving some input data like fox or some data. It can be binary, text, any data, some byte stream we are giving as input to the cryptographic hash function such as SHA-256, something like that. It will provide some digest value. So it will be, so whatever the input length, the digest will be of the same length. It's a fixed length digest we will get, and for every input the data digest will be different. Even there is a minor change. If you think these two sentences, the only change is instead of v here it is u. So even the minor change actually caused the digest to be completely different, right? So that is very much needed to verify the block whether any tampering happened. So for example, we have a transaction recorded in the blockchain saying that a transfers 100 rupees to b, but if somebody tampers it to 1,000 rupees, then when we verify the digest, we can see a huge difference between these two statements. It may not be visibly immediately seeable, but when we look into the digest, we can quickly see the difference, right? So that way, hashing is very important for ensuring the data integrity, checking that one. And digital signatures. So every transaction when the user submits or some data to be added to the blockchain. So submitting the data, while submitting it, we have to make a signature of it. Okay, I am the user, the originator is proper originator. So we need to verify that. For that purpose, we use digital signatures. It shows the authenticity of data. It can be made only by the person who has the private key and verifiable by anyone who is having public key. So if we there will be two keys, one is for signing the data and one is for verifying the data. Verification key can be public, anyone can have it, but signing key will be very private. So for example, when we download some software from Microsoft or any other people, they have the secret key, they sign it on the software, so that we can be sure that it is a real software from Microsoft. It is not somebody tampered it or maliciously added any virus or malware in it. So to ensure that people make the signature, right? So similarly for transactions also, to say that it is really originated from Alice public private key, using private key, she made a signature. So that is the another building block of blockchain. Then moving to smart contract. So as I mentioned earlier, smart contract implements business logic. Maybe the full business logic if it is a small blockchain based application like crowdfunding, voting and things like that. But it can be a partial business logic when it is added to a legacy system, means existing system. So existing system may have the entire business logic. Some part of it will be added to smart contract. So if you take Hyperledger Fabric as an example, the smart contract or chain code, we call it in Hyperledger Fabric, it has a set of functions, so which implement the business logic. So when we call it, when we call a function to be executed, that is a transaction. So transaction says maybe like this one. If you take this example, it's a very simple example without any error checking and all. A transfer smart contract. It transfers from the source account to the destination account to the amount, specified amount. So we are getting the current value from the ledger for the source account. We are getting the current value for the ledger for the destination account. We are doing the appropriate calculation and putting the value back into the ledger. So this is the operation any smart contract usually does. So when we execute a smart contract, we call this way, okay, transfer from A to B 20 rupees. So, so what happens? This execution will be done by all the peers independently. So peer A, peer B, peer C, we can say that all receive this transfer request. So they independently verify with their ledger, okay, what is the current balance of A, current balance of B, and they do the computation and they propose the new change, that is what new value to be set to the ledger. So we can say that peer 1 says A balance means new balance of A 80 and B balance 20, this to be written in the blockchain. So see, you can see that everybody come to the same value because there is no everybody's ledger is not it's in proper shape. In case some ledger has been tampered, let us assume that somebody changed their blockchain by directly getting into the file system level and modifying the bit values and things like that, then maybe one of the peers may come up with a wrong result. Maybe A balance can be 800, something like that it may come up with. But what happens in the next, in subsequent steps, it will be eliminated, that we will see. So ideally in a proper scenario, all peers will come up with the same endorsements, same values. Then next step is ordering or broadcasting, ordering and broadcasting. So here oh, I'm again coming to the Hyperledger example. So what happens, there will be a ordering service. Every peer shares their data with the user, and user finally shares the transaction to the orderer. So orderer will keep waiting for such transactions. So every transaction has the information like, okay, transfer A to B 20 rupees, the original information requested for, and the after execution, what is the endorsement, what is the new changes that is submitted by the peers, computed by the peers. So similarly, multiple transaction may be there, right? Multiple transfers will be there, or multiple smart contracts doing different activities. Everything will come into the blocks. So here ordering will happen. So every transaction is ordered and then broadcasted to all the peers back. So now every peer got this information, this block. So block 10 is in process. Let us assume that we are now processing block 10. So transactions in block are verified on each peer. So now what we are doing is we are validating the transaction. So we take transaction 1 and we check what is the proposed value, new proposed value by different peers. So we check the signature. So verification will be a process where all the information will be checked. The signature of the block creator, the the endorsements provided by different peers, all these things will be checked against some endorsement rules. Okay, if majority of people say block this transaction is success, or majority of people say that transaction with the same output, then we can assume as this is a valid transaction. Then finally the commitment will happen. So for committing, they will this is the process in which actually the block is added to individual blockchain. So every peer will add to their own blockchain and another block. So block 10 is added to all the blockchain. So this is the smart contract commit process. So until now we have seen the building blocks, what are the parts of the blockchain, like blockchain is there, smart contract is there, how smart contracts works, the life cycle kind of thing, and how it is being stored, right? So now what is the advantage? Okay, everything is fine, technically this is fine, but what we achieve by using that? So anonymity, if you take permissionless blockchain, in case of permissionless blockchain, we don't have any username password, or we don't have to reveal any identity while joining the network, right? So we can do transfers and things like that as an anonymous identity, and as well as there is no central authority, right? So no one is having any control over it, in the sense that no one will be controlling the entire blockchain, and the way the changes happening in the blockchain. So this is an advantage when multiple peer to peer kind of relationship, people with peer kind of relationship want to build some solution. So this is where the control comes. Participants have more control over the data entering the blockchain. So individually I am writing into my blockchain, the other person is writing into their blockchain. We are not simply copying their updates. So that way I can be sure that my copy is always correct. So that kind of confidence we can get. So similarly, auditability and data integrity. As I mentioned earlier, every data coming into blockchain is recorded as a transaction. So the transaction history is there, and the history cannot be tampered, right? If the history is tampered, it can be verified cryptographically. It's verifiable, right? So we can verify and see some tampering happened. So that way you don't have to create any separate audit trails. It by itself has the audit trail, and data integrity is ensured. And coming to the transparency, since data is shared across parties, everybody is having their own copy of it, and whenever transaction comes, everybody replicate it, right? So the data is immediately available to all the parties. If you consider a big scenario where multiple parties are there in a shipping industry, so when the consignment is shipped, everybody will come to know, okay, this consignment is shipped, so we should be ready with all the services whatever we are providing, whether we provide the logistics or vehicles and things like that, we can be ready. So this transparency will be useful in that sense. And coming to the so finally, altogether, it brings trust among mutually untrusted parties, eliminates the need for intermediaries. So you usually, if you want to communicate with other untrusted party, we need a trusted third party, right? Whom both of us trust. So they act as the intermediary. We give it to them, they give it to the other party. So that way they arbitrate the things. and it costs also, right? We need to pay something for that intermediaries. Now, since blockchain is there, everything is stored on each side. It brings trust by technology. That way, we don't need intermediaries. We can say, for example, uh, right now, if you take we can see Uber, Ola kind of people who and car owners or car people joining with them, and they run their things, and part of the amount they have to give to Uber and Ola kind of people, right? So if there is a blockchain which everybody, the car owners together maintain, all the information will be shared by everybody, right? So that way, if they build an application, they can build a taxi application using blockchain without any intermediary. So they all can share the money within themselves. So that is an advantage. So that is what we are going to see in this slide, what kind of problems blockchain can solve. There are so many things we can imagine for blockchain. For example, in fraud detection, if we take what kind of frauds can happen and how blockchain can solve in that one. So, for example, if we take backdated entries, a kind of fraud which can happen in use cases like organ donation, where people register for organ, the beneficiaries register for organs and wait for their turn, right? There will be first come first serve basis. So if somebody is trying to change their date so as to it's like, okay, I registered on certain date, but they pay some bribe or something like that. If they can manage to move their date somewhat ahead, they can get the organ earlier, right? So that kind of thing may be possible in a centralized setup, because they can simply bribe a database admin. If he's a corrupt person, they can try to manipulate. But when comes to a blockchain network, multiple copies are there, and these copies are independently maintained. There is no one single authority owner. So even if tampering happened in one node, the other nodes will have proper data. So when consensus happens, these wrong details will be ignored. So that way, it can help in avoiding fraud. So you can relate to several other places also, right? Employment exchange, we should be given priority based on the date where we registered, right? So backdating should not happen. So these kind of things we can see blockchain will be very useful. Then access control, to ensure access control, double funding kind of thing in trade receivable discounting system. So one general point is, blockchain as a technology will be useful in many cases, but it is our domain knowledge which will make it very valuable. With domain knowledge, we can say where it can more appropriately fit. So that way, this double funding is a system. Not double funding is a fraud which can happen in the trade receivable discounting system, where when a manufacturer gets an invoice order, with that invoice, if it is a invoice for 1 lakh rupees, they can go to a finance institute and they can get a discounted amount upfront, like yeah, 80,000 rupees they can get upfront, showing the invoice, so that they can pay, the finance team can get it from the actual customer, the actual 1 lakh rupees. So this discounting will be a quick kind of financing thing. So what happens if these people, the multiple financing people, doesn't have a transparent system in sharing the information? The manufacturer can actually show the invoice to multiple people and get funded. So these kind of frauds happen because of lack of information between multiple financial institutions. Similarly, duplicate identities kind of frauds can happen in the know your customer cases. So how blockchain can be useful in this scenario, or tamper evidence, right? So if there is a tamper in blockchain, we can verify it, but in the centralized case, it is not possible. Similarly, transparency of blockchain helps avoidance of frauds and insider threats. and traceability issues. So provenance of goods such as food items and other high valued items such as diamond in supply chain. So these things again, you can see, you might have heard of IBM's food trust. So they trace the foods from its origin. So if there is a kind of pandemic, some kind of disease is spreading from food originated from certain location, then if they know that okay, these are all the batch of food comes from that location, they can actually isolate that food instead of completely destroying all the food. They can do that kind of things. So for that kind of places, blockchain based solution will be very useful, because multiple parties will be involved, right? There is no one can keep the centralized thing, database. Similarly, diamond and several other use cases are there. You can see in the internet traceability related use cases. So blockchain stores and shares records about every movement of assets. So every stage, we can track the data. Then discrepancies in siloed copies of data. So right now, if you see some of the business processes like interbank payment. So interbank payment requires a lot of efforts in a reconciliation process. So which means, so the entire day between banks there will be request. Okay, from my bank you have to pay some other bank's customer. So between them there will be multiple interactions. Okay, from here to there, there to here, like that. So at the end of the day, they do some reconciliation to see whether they matches the request and the request is being served, right? So their data matches or not. It seems currently it is a laborious process. It requires a lot of effort. So what people suggest is we can use blockchain based solution, so that banks can independently maintain their record, but the reconciliation happens immediately. Whenever the somebody submits a transaction, it will be uh, um, immediately stored in the database after consensus, right? So there is no need of external explicit reconciliation by human. So similar case you can see in call detail records between telecom operators also, because telecom operators serve each other, like one network to network if we call, so they have to serve, right? So those kind of places also, this is very useful. So instant reconciliation happens in blockchain. Then coming to the issues with centralized solution in multi-party scenario. So what are the other solutions? So trust issues when parties are mutually untrusted. That we saw, right? When there are multiple parties, but we don't want to trust each other, then we can't go for a centralized solution. I mean, centralized solution means somebody will, we need to trust, that person has to host it, right? So that places blockchain can help. Similarly, control issues when the parties are almost equal size. So, if multiple banks are coming into play for a interbank payment kind of solution, then if they are everybody wants their own control, right? They don't want to give the control to a single bank and all of them will log in and update their data. It won't happen. They want to have a peer-to-peer kind of relationship. So, and solution also peer-to-peer control should be there, and vulnerable to single point of failure. So if some places high availability is needed, there also we can consider blockchain. But we need to see whether blockchain is the optimum solution, that we will see later. And wherever you think that intermediaries taking major benefits, where we can remove intermediaries with blockchain, then that places will be good opportunities for blockchain. So blockchain empowers every participant equally, enable consortium control. That way it is good. Then inefficient processes. So some cases in shipping industry and places, it seems there is a lot of delay caused by the lack of data available at the right time. For example, shipper ships some data and the papers are moving in different channel. So when the paper doesn't reach the right authority, portal authority or the airport authorities, then the movement of that shipment will be delayed. So that causes a lot of what to say, losses, right? If they have to keep it, so they have to give the rent and things like that. So those delays are actually a real problem. You can see IBM Trade Lens, one application there. They are using blockchain Hyperledger Fabric to address this one. We can think of similar scenarios. So availability of data to all participants speeds up approval processes and preparedness for providing services. So similarly, when we know there is some order happen and things like that, the entire pipeline can the people in the entire pipeline can be ready with that, right? They okay, we have to provide this service. There is a huge order, we should be ready with that. So something like that. And some of the industrial use cases which I mentioned earlier, you can see here. This is high level of information, like where and all people are looking for blockchain. So supply chain, food safety, logistics, oil supply chain, diamond tracking, even fish, some special kind of fish tracking you can see in the internet, and like energy trading and several other places people are looking for blockchain. So at the base we can think wherever multiple different parties involved, then blockchain is a good candidate for creating solution. So similarly here we can say interbank payments. So banking is a very prominent users of blockchain. They are actively checking for blockchain use cases because money, everything is already in digital format, right? So in blockchain, converting digital tokens, everything is easier. So banking is one of the important people for blockchain use cases. So JPMC Interbank Information Network. So these are all for sharing the information between multiple banks while doing interbank payments. IBM blockchain, Worldwire, Swift plus R3. So Swift is the current the interbank payment between multiple countries, right? So these all of these people are trying to address so that the interbank payment will be very speed instead of currently it seems it's taking in days. So they are trying to make it instantaneous, like our interbank payment between within the country. Similarly they want to make it. So then fair trading. So as I mentioned earlier, so somehow when we do the trading, actually most of the or significant portion of the amount will be taken by the intermediaries, right? We can see that farmers and when the people buy the products from farmers, the amount will be very less. But when it comes to the market, it will be very huge, right? So some amount, something we cannot avoid because the storage and maintaining things like that will be there. But some intermediary costs we can cut down. So for that, they have fair trading kind of use cases. So Moi Coffee, Starbucks, they have some solutions based on blockchain where the buyers can actually give some money specific to the producers. So that will bypass everybody in the pipeline. They will directly go to the manufacturers. So that way they are trying to bring some good value to the life of people from Ethiopia and African countries where actually they farm coffee beans, even though the coffee beans are actually what to say sold at very high cost, but the farmers are not getting the benefits. So this kind of fair trading they are trying to enable with the help of blockchain, improve the people's lives. So that is very interesting use cases of blockchain. Then identity management. So self-sovereign identity related, for example, Hyperledger in Indy, IBM identity mixer. So they are trying to build a identity network worldwide, so that instead of providing so many cards, ID cards, local ID card, international ID card, several cards, we can have a single identity in the blockchain. So whenever we want to prove something, I own a I'm okay having driving license, or I have a Aadhaar card. So instead of that, if you want to prove a particular possession of a particular thing, we can we can do self-sovereign identity kind of solution. So identity management helps that. So blockchain is a viable solution to implement such solutions. And healthcare, so pharma supply chain to avoid counterfeit drugs. So counterfeit drugs is one of the challenges for pharma supply chain and patients' health record maintenance. So if patient's health is maintained in a healthcare network, even he is traveling from one place to another place, if some emergency situation somebody has to provide some immediate health care things, they can quickly check their from the network. They can quickly take the information. Okay, what kind of medication he is going under, that kind of information we can get. So that way it will be very useful. So blockchain is the only or blockchain is the more suitable enabler in that kind of use cases. So some day-to-day use case we can think. This again comes to a close group. See, we have several WhatsApp group and things like that, right? So maybe we can think, okay, um, um, some insurance, mobile insurance. Some people said, okay, we will put some money, and if somebody's mobile phone is broken, the money can be used by him or her. Like that, we all contribute to the insurance. The insurance amount is with us only, right? Maybe if no one claimed any money, actually we can share that money at the end of the year, right? Now if we do any insurance, we are paying to the insurance company and we don't get it back, right? Even if you are not claiming, but and we don't know how many people claimed or not. But if we do it within a group, we are actually putting some amount in the corpus of fund, and if no one actually claimed, that corpus can be shared among us, so it's a benefit to us, right? So that kind of thing we can do with blockchain when there is no mutual trust. So that way we can see. So here there are some examples: credit amount maintenance, like between shopkeepers and suppliers. So suppliers supply goods to many shop. If they want to, right now maybe they keep separate records, right? Shopkeeper maintain one record, and the supplier maintain one record independently. They manually write it. So instead of that, we can have a mobile application, so they can simply say this many goods have been delivered to them. Immediately this will be reconciliated, so they can accept it based after checking those things, right? Some workflow kind of thing we can make it based on blockchain as the underlying mechanism. So peer-to-peer insurance, just now I explained, we can have such things. Then chip funds, here also we can think of blockchain. And taxi booking, which I mentioned, right? So Ridex and Uber blockchain also exist. They try to use blockchain as the base. So as a caution, maybe we can say, even though blockchain technically brings some trust, um, trust is not only that, right? Whatever blockchain brings, there should be something more. So that we will see at the challenges part. But just to give a precursor, I'm telling that now. So here is a sample, very simple scenario, and we will see how we can apply blockchain to this scenario or how it can help. Um, so in order to keep it simple, I'm taking a very simple use case which we see in day-to-day life. So this is for credit account maintenance for packaged drinking water supply. Let us assume that we might have seen that, right? Everywhere near the shops, people come in small lorries and they put the packaged drinking can to the shopkeepers. So they maintain records, right? So here the participants are packaged drinking water supplier and a few shopkeepers. So this is the scenario. So the ledger, what is going to be the ledger? Currently they are maintaining independent books to keep track of supply records. So what is the issue we are trying to solve is data mismatch and reconciliation efforts. So sometime what happens, they supply 20 water cans, they might have recorded as 21 or 19. So some mismatch can happen. So proposal of keeping a single central copy by the supplier is not accepted by the shopkeeper. So supplier says, okay, instead of maintaining separate copies, let me maintain the single ledger where we will record all the information. But the a shopkeeper will not accept it, right? He wants to have his own copy. So that is the issue. So a solution proposal, let us assume that the one of the supplier's son is a techie, and after hearing the problem, he's just suggesting, how about using a blockchain, dad? So he's asking. So now we will see what proposal he made, the techie son. So like water chain. So blockchain based solution for packaged drinking water supply record maintenance, okay, between supplier and the shopkeepers. So there is a mobile application for supplier and shopkeepers. They can open it in their smartphones. A backend powered by blockchain. So there is a lightweight peer node run inside the mobile phone. When the application has this component, it's a very lightweight thing. Live ledger updates and notifications. So when the supplier says 20 water can has been supplied, when he enters into his supply chain, it will be notified to the shopkeeper also, and he can accept it or whatever, he can raise dispute or things like that. So smart contract implements the needed APIs to record delivered water can count and amount paid to the all information to the ledger. Also APIs to query balance amount, list of shops from the ledger. So these information can be queried from the ledger. So corresponding APIs will be implemented, and solution well received by the shopkeeper. So now supplier and shopkeepers are happy. They don't have to maintain manual record. So what happened over a period of time, they are coming up with additional requirements, or we can say these are all the privacy constraints. So one of the challenges in blockchain. So shopkeepers may come up and say, I don't want other shopkeepers to see my purchase data. So because you know that blockchain is a broadcast or shared database, right? Everyone can see the data in their what is going into the blockchain. So that is one of the issues raised by shopkeepers. I don't want the other shopkeeper to see how many cans I am purchasing and things like that. And suppliers, from suppliers point of view, he want to give some custom discounts to different shopkeepers. Maybe a shopkeeper may be purchasing a large number of cans, or they promptly pay the dues and things like that. So he may want to give some discounts to the particular supplier. So if we keep it in the blockchain, everyone will see, right? That will cause some confusion. So some privacy is needed. So similarly, so what they propose, the techies, and again, is privacy enhancing features like channels in Hyperledger Fabric blockchain. So Hyperledger Fabric has some mechanism called channels, where we can have multiple small blockchain in the same infrastructure. Similarly, Corda distributed ledger technology, where the default is the only the participant will keep the record. So that kind of things will be there. So encryption we can consider, or zero knowledge proof based techniques. So those kind of options are there. So these are all the things. This is for the morning session. Maybe the technical challenges onwards, I'll keep it for the afternoon session. Maybe if you have any questions, we can discuss now. I'm stopping here. Any questions?
Any questions?
Sir, I'm Ramchandran here.
Hi, Ramchandran. Yeah.
With respect to your final slide, you were telling used case, additional requirement for privacy and water chain. It was interesting to know the used case. And I'm from a manufacturing background. We are using a lot of centralized system of computers and other things. So
Okay.
in case of identity management, what you told the earlier case, it's a hyperledger fabric, and you have different types of proposal which you are giving there. So what is the basic difference between hyper fabric and Corda and zero knowledge proof? Any is all the one and the same? Only any advantages or disadvantages available? it's a permissioned blockchain, I hope, so that it will be used in a within 2 or 3 users.
Hyperledger they maintain different blockchains, so that will be maintained between that shopkeeper and the supplier. So it is only between them. Whatever discounts what they give, everything will be within them. So similar, that is one kind of approach. So every approach has its own what to say, we are indirectly we are having multiple small blockchain kind of thing. If we come to Corda, Corda by default says there is no broadcast to every participant. It will say for a particular transaction who are all the participants. If it is between supplier and shopkeeper one, then the data will be shared between supplier and shopkeeper one. So that way their vault or their ledger is designed. When we say zero knowledge proof and encryption, this is common technology when we can use with any blockchain. For example, if we say encryption, what we mean by this is, if a data is meant for shopkeeper one, we encrypt the data with shopkeeper one's key, so that only shopkeeper one can see. Even though the data is shared with everyone, others cannot see. So that way encryption come into picture. Zero knowledge proof is also something similar. We can selectively disclose some information, that kind of thing we can do. So this is the difference. So while choosing the platform, based on the use case, we can choose whether to go with Corda or whether to go with Hyperledger Fabric things and things like that. So if the privacy requirement is clear, we can appropriately choose the platform. Yeah.
Fine. If it is for a secret service, then you can use for a encryption model, and if it's for a general application, you can go for a fabric model. That's
yeah. Even in Fabric, we can, on top of Fabric also, we can encrypt data and share it. So it is like people will know, okay, some transaction happened between supplier and shopkeeper one, but we don't know what it is. So that kind of thing. So some amount of information will be there in that way. So encryption is like we were giving information to everyone, but the key only one the relevant people can open and see. If you take Corda, we are giving information only to the relevant people. There is no one, what is it, others will not even know what happened between them. So that kind of thing. So yeah.
But all these data to be within the two peers computer, or it will be in cloud computing? Is there, when it goes out of internet, when it is in the cloud computing, anybody can tamper it or anybody can see it? Is that
Actually, storage will be with the peer computers. We can say that I am using my laptop as a computer. Okay, I am a peer, so it will be there in my computer only. But if I am running my peer in cloud, it can be in the cloud, but still within my storage only. It is not a public thing. What we mean by public, or what we mean by shared, is shared across my computer, your computer, and whoever in the participants, so we all can see. But if you want, you don't want to share something with me, but in the network some of the part of the people you want to share, then we need to think of how we can tweak the blockchain, or what feature we need to use. Maybe you have to create a separate channel with that group. So something like that we need to
that's
do.
what. In case of defense related work which somebody is doing, or a national security point of view, and if two informations or identity has to be maintained from the start to the end, but this will go through internet and it will be stored in cloud. But as a national security, this cannot be stored in a cloud. So
Okay.
is that really, this will be useful for that situation? That's my
Yeah. We can use that situation also. If there are multiple parties, but we don't want to store it in cloud, then we can build a blockchain based solution. We can run the peer nodes in premise on the multiple manufacturers and whatever participants, stakeholders in that ecosystem. So it resides in their computer only, but it goes through internet because all the computers are connected through internet, right? Or some network you should establish. But that between them it will be a, what to say, secure connection, so no one can look into it. So that way
Even
it can add.
even if he looks inside that, he doesn't have my private key or public key to find what's the data available inside that. But he knows a transaction is happening, but he cannot see what is happened inside, correct?
Right. If the third party also eavesdrop the connection, yeah, they won't be able to see the data. So we need to, yeah, if we know the threat model, what kind of threats are there, we can appropriately design encryption, as you said, encryption we can do, then no one can see. And by default also, if it is a encrypted channel, like TLS connection and things like that, then people won't be able to see what is going inside. So yeah, you are right.
Okay. Okay. Thank you so much.
Thank you.
Yeah, I have one question. Since this cryptocurrency is banned in India, so for the application, if you need currency, how maybe in the applications, some applications maybe you may need transfer of money, and how it is done?
Okay. Oh, okay. See, currently, if you are building some new application, let us assume that interbank payment kind of application you are building, then we don't want to use cryptocurrency at all. We can use the blockchain platform like Hyperledger Fabric or Corda, something like that. We can take. There we can define our own currency or our own token. So the token will represent the currency in their Bitcoin, in their blockchain network. So that way we can create our own currency there, or some tokens as a representative of money.
Or some kind of private currency.
Yeah. Some kind of private currency kind of thing.
So,
It may not be valid outside, but it is only to say that, okay, I owe you 1,000 units of money, something like that. Then some other manner, the bank can actually pay the actual money. This is kind of tokens only.
so then this party should trust the currency, something. Should trust the coin, something like that.
So here, how usually they do is maybe that trust should be there because they together forms that currency, right? So they should have they are coming together to form the consortium in the enterprise case, right? So in the consortium, they decide, okay, for each amount of money, we will create this much, what to say, uh, tokens in the blockchain. So when they request for 2,000 rupees to be transferred from source account to balance account, instead of actual money, they transfer the tokens. Then at the end of the day, how much tokens each people have, they have to redeem it, or they can continue function in that way. But yeah, you are right. They have to trust the token, whatever they are creating. So that level of trust is needed. It is not technology that can bring the complete trust.
Yeah. Yeah.
Sir, in respect to this water chain, you have developed a peer-to-peer this network. If a person wants to do this, what will be the cost of this package or to run it? He has to, every month he has to pay to the developer, or
No,
he can run it in his peer, and once for developer is not there. What is the cost involved inside?
okay. That is just as illustration purpose. I created a proposal only. It is not implemented. But if when you actually really need it, we can hire a developer and ask them to implement it. That's all. The one-time payment only. Then okay, assuming that you are the supplier, you want to develop such thing and you want to give it to your shopkeepers or whatever, whoever the customers you are having, then you can actually hire some developers. I don't know how much they cost, people ask for, or even if we can learn about blockchain and we can develop, it's a matter of time only, without any additional cost. So once it is developed, there is no monthly payment or nothing like that. It's a one-time.
It's a one-time charge for the developer, and it's a permissioned blockchain method of using, and our own PCs will store the data. So if we want, we can resolve it. That's the thing.
Exactly.
No need of any transaction charges like our screenshot methods here. It's only between the customer and the supplier and the manufacturer. Somebody will.
Right. Yeah. Whoever they're in the network, only within them. Correct. So you need to have some network. Once you can connect to each other, then that's all. Yeah, the application everyone can independently run and do that.
But if there is a dispute between these two parties, and if they want to resolve it, is there any law available in this country to solve this?
I don't think so. As far as I know, there is no law. See, this is for this is for as of now. I am viewing it for error detection or correction kind of thing, in the sense that not what to say. Unknowingly we make mistake, right? Manually, if we write independently, we may create mistakes, right? This can actually resolve that one. In the same At the same time, it is not giving one person the entire control. Then he can actually modify the database and things like that. So it is a balance between that. But really, to that extent, whether if we want to there is a dispute due to something and legal actions for those things, I don't think it will be a valid evidence. I am not sure about that.
Okay, there is no. It is not as per any government of India law or anything. It's between peer to peer. So there is no intermediary available. That's what you mean.
Yeah. That's how my understanding is. Maybe some legal person can clear it. Yeah, my understanding is that much only.
They are telling you can use it in land registration, and you can independently do, or for you can use it for any rental agreement or something like that. If there is that's my query. I and the second party doing this blockchain method, and I'm paying to him, and he's getting the money. But if is there any chance of dispute? Who will be resolving it? That's the
Okay,
whether
see,
develop.
if it is implemented in the land registry level, then they should actually, the authorities, land registry authority should be providing that kind of trust, or that there should be some clause which says that this can be taken as the evidence, or things like that. So if it is in that scale, maybe the law enforcement may come into picture. But at a very low level, when we two individuals within friends, if we implement and things like that, I don't know whether